So the first important concept that needs to be addressed when we're trying to figure out how an EKG works is how charges that are moving inside of the heart actually get detected. And the reason we need to talk about this is because this is the way EKGs work. They work by detecting how charges are moving around inside the heart. So in order to understand this, what I'd like to do is to talk about how charges are detected when they're moving around in general, whether it's inside the heart, inside a different organ of the body, or outside the body in some other situation, say in a chemistry lab for some kind of experiment. Once we figure out how moving charges are actually detected in a general situation, we can then describe how they move around in the heart, and we can go and talk more about how they apply to EKGs in general. So, the first thing that we need to address is the way the charges that are moving around are detected. And they're detected using a special sensor called an electrode. And the job of an electrode is to sense currents that are moving through a solution, or to sense moving charges. Now, electrodes come in pairs, and therefore there are two kinds of electrodes. The first kind of electrode is called the negative electrode, and the second electrode type is the positive electrode. So the way electrodes work to sense charge is they compare what the negative electrode is seeing in terms of charge versus what the positive electrode is seeing in terms of charge. To make this clearer to you guys, let me walk you through an example. Let's say you have two solutions, which I'm going to symbolize here by boxes filled with a liquid. So imagine that there's a liquid in both boxes. And let's say that the first liquid has 4 more positive charges than negative charges. So imagine that the rest of the solution is filled with positive and negative charges, but the numbers are equal and they're 4 extra, which I've shown in green. Now, let's call the solution 1. And now let's talk about the solution on the right, which I've labeled solution 2. Let's say that the charges are completely balanced in solution 2. And for effect, what I'm going to do is just draw 2 positive charges and 2 negative charges. But really, the charges are balanced in solution 2. So comparing the two solutions, you would say that, of course, the one on the left is going to be more positive than the one on the right. And if you were to quantify that, you would say the solution on the left, or solution number 1, has 4 more positive charges than solution 2, that is, in net. So how do you detect this with an electrode? Well, you put one member of the pair in one solution and one member of the pair in the other solution, and you connect them with a wire, and in the middle of the wire is a meter called a voltmeter. And you would also connect the solutions using another tube that lets charges move. So what you've done in this situation is you've created a loop between the two solutions, or a circuit. If you were to trace it, you would see a path somewhat like this. If you started in solution 1, it would go up the tube, down into the other solution, up the electrode, through the wire, through the voltmeter, which is key, and then back into the electrode, back into the solution. So I'm going to clean up this diagram so that you can see better what I'm talking about. Anyway, and the reason that there's movement of charge along this path is because there is an imbalance in the charges between solution 1 and solution 2. And when you connect things like that, if you connect unbalanced charges, you're going to move the charges until there's some kind of equality. So that is the way that the electrodes work. Now, how do you get a reading out of these electrodes? Well, the key is that the charges move through the voltmeter as follows. And once they move through the voltmeter, it gets excited and says, hey, I'm detecting movement. And it can quantify that movement in the form of a voltage. And the voltage is a good estimate for the difference in the potential between the two solutions for movement of charge. So charges are detected, in a sense, by the electrodes based on how likely they would be able to move between the two electrodes if there was a circuit between them. That's how charges are measured. Now, something I forgot to mention when I was drawing this diagram is it's important to consider which electrode is which. So the electrode in solution 1, I'm going to call it the positive electrode, and I'm going to call the one in the neutral solution as the negative electrode. Regardless of which one is which, however, you have to determine which electrode is going to be the one in your neutral or ground position. Versus the one that's in your test position. So since our neutral or ground solution has the negative electrode, we're going to establish the negative one as sort of the baseline, and we're going to call our positive electrode right here as the one that is detecting the charge, and we're comparing it to our baseline position. Okay, so now you understand how an electrode works. It works by a comparison. From now on, what we're going to do is we're just going to consider the positive electrode and what that positive electrode sees in comparison to our negative electrode, which we will say is sitting in some neutral solution, which is going to be the point of comparison for whatever the positive electrode is seeing.